Let's have a look at doing the OCR Core 1 January 13 paper, question 10. I've picked this question because lots of people guess it wrong. It's asked us to find the coordinates of the point where the curve y equals a third x cubed plus 9 over x has tangents parallel to the line y equals 8x plus 3. So let's have a look at what the graphs look like. The graph in red is the graph of a third x cubed plus 9 over x. The graph in blue is our line y equals 8x plus 3. And the question's asking where, if I draw a tangent onto the red graph, at which coordinates would my tangents be parallel to the original line? So the first thing that we're going to need to do is we're going to need to find the gradient of the original line. We can do that because we know that it's in the form y equals mx plus c, and the m part is going to be our gradient, so we can see that the gradient is going to be equal to 8. So now we know what the gradient is, we need to find where the gradient on our curve is also 8. So to do that, we're going to start with our curve y equals a third x cubed plus 9 over x, and we're going to have a go at finding the gradient function. So for that, we're going to have to differentiate. Now, before we can differentiate, we need to have the equation of our curve in a polynomial, which means it's all a number times x to a power. So we need to rewrite 9 over x as 9x to the minus 1. Now it's in a form I can differentiate. We're going to times by the power, which gives us 3/3 or 1x squared, because we take 1 off the power. And then when I times by the power, I'm going to get minus 9x, and then I'm going to take 1 off the power. I want to see where this is equal to 8, because that's the gradient we're after. So we get 8 equals x squared minus 9x to the minus 2. Now we've got to solve this to find out what x is. The key thing here is to spot that it's a disguised quadratic. To get to that, we're going to multiply through by x squared. It might be easier if we write this as x equals x squared minus 9 over x squared. It becomes a little bit more obvious then that we can multiply through by x squared to get 8x squared equals x to the power 4 minus 9, or x to the power 4 minus 8x squared minus 9 equals 0. So from here, we can make a substitution, and we can say let's pick a letter. I'm going to pick p equal x squared. No real reason for picking p, I just felt like it. So we can rewrite our quadratic now as p squared minus 8p minus 9 equals 0. This factorizes nicely. It factorizes to give p minus 9 and p plus 1 equals 0. And so p equals 9 or p equals minus 1. But if you remember, we weren't using p, we were using x squared. So let's replace p and put x squared back. So we get x squared equals 9 or x squared equals minus 1. Now to find out x, we've got to square root it. I can square root 9, but I cannot square root minus 1, so that's not going to give us a solution. When I square root 9, I'm going to get x equals, and we've got to remember, plus or minus 3. We need the coordinates. Well, we've found the x coordinates now, but it's plus 3 or minus 3. Now we need to find the y coordinates. So to do that, I'm going to substitute our 3 back into the equation, which will give us this. 3 cubed is 27. 27 divided by 3 is 9. So I get 9 plus 3, which is 12. When I substitute in minus 3, I'm going to get y equals a third minus 3 cubed plus 9 over minus 3. And that will give me minus 9 -3 or -12. So now to finish off a question, I just need to give both the sets of coordinates. So I'm going to give my answer. The first set of coordinates is going to be 3, 12, and the second set is going to be -3, -12. Let's quickly check that that makes sense for our graph. So if we come back here, we were expecting 1 around here in the positive quadrant and 1 in the quadrant where x and y are both negative, and that makes sense for our answers.